Good evening! It's time for another Voron live stream on a Sunday evening at the same time that we normally do. And this week is going to be a pretty exciting week. This stream is going to be a pretty exciting stream. We're going to start by powering on and seeing if it all explodes. And provided there are no problems or problems that we can easily fix today, we shall go ahead and do those, and then we're going to do some Klipper fluid configuration for firmware. That's the plan, and I think we're in a pretty good stage to be able to do that. And hello and good evening to everyone in the chat, especially those that are new, and also to those who have joined before. Welcome back. I was not having tech problems, by the way, but a good guess. That's normally what's happening. Today I was just a little bit slower than normal getting stuff ready. So, as I mentioned, there are some differences to last stream. I believe I've finished the bed off, right? We had that off at the end of the last live stream, so that's on there now. Everything's wired in. We did all the views and stuff, didn't we? That was just sticking on the back. It actually didn't really take many hours to cure, so that's all good. I've actually changed the Z drag chain at the back to the same dimensions as these X and Y ones. The reason being, it didn't seem to fit very well. End of story. It didn't fit. So, like when this X carriage was all the way at the back, it was rubbing on the drag chain. It didn't mount properly. The whole mounting was a mess. So I was like, scrap it. Don't need that size chain anyway. So I got rid of it and just put a normal 10 by 11 in. Seems absolutely fine for this wiring harness because, well, the wires are pretty small and they're all very slippery, so shouldn't cause any issues. I also have adapted the bit that you can't see down here. Let me move the printer around a bit and then you can see. Let's go nice and close. So, this piece here, by default, has no place to zip the cables to, and it's important to get these rigidly mounted at both ends of the drag chain. Unfortunately, not being able to do that at the other end of the Z drag chain, but it's a good start. Vector 3D, does the bed need to move back a bit? I have no idea. We'll find out later on. I think it's okay, but it might be a little bit too far forwards. Not sure at the moment. Yeah, so I've redesigned this. It's now using 3 holes to mount instead of the original 2 holes, and it doesn't use that annoying kind of plate on the back. It's just some 3 threaded inserts. So that fits and is a bit more supportive. I've also added up here, which you can't really see from this angle, but normally this drag chain would just flop backwards that direction, but I've put a stop in here so it doesn't just fall. How can we show that? I'm conscious of breaking these skirts. Oh dear. Try not to slide the entire printer off the desk. No. There you go, you can kind of see it at the back there now. It's kind of blurry. There you go, next to the drag chain. I realised in the process of designing it, in fact, as I fitted it, that I think there actually is a part in the printed parts that I was delivered that already does the job that that part does, which I'd obviously just designed, and that looks like this, like that. And I think that face there, this one, is there to slide on the cable chain, because I have no idea what else it's for, and it doesn't seem to be anywhere in the manual of how to assemble it. So that's why that's not on. So we're going to start. Chat seems quite quiet. Everyone say hello. Say hello. Don't be shy. It's okay. We're going to get started with this power on test now that I think I've covered all the things from before. Oh, there was one other question as well. Somebody asked about whether you need to earth or ground, the same thing, the frame. So connecting it to your yellow-green cable that's connected to earth through your mains cable. So I've tested this by connecting the normal earth connection to the bed, which I 100% recommend you do. And then I've tested all the way around the frame in a whole load of different locations to see if you still get continuity on earth right from the connection out the back. And you do. So on this printer, because the frame is connected directly to the bed, you can see like the screws are directly to the frame is connected to the rest of the frame. You don't really need an additional earth for all the other parts of the frame. They're all connected to each other anyway. And for the same reason, the DIN rails, although the power supply is connected via plastic parts to the DIN rail is obviously connected into this frame, which is already earth through the bed, so there you get earth as well. The only place you don't is on the carriage. Well, yeah, any of the gantry, because the gantry is not mounted via any metallic parts to the rest of the frame. But I think that's going to be okay. There's no high voltage, excuse me, there's no high voltage on that gantry, so I wouldn't consider that to be a problem. Hello, hello, hello. Good to get everyone there. Wire cover. Which wire cover are we talking about? The one that I haven't shown you yet? I don't know what wire cover you're talking about. But no, but you have reminded me of a wire cover that I do want to show you. So underneath, this is one thing that I prepped for today. I was a little concerned, only lightly, that there was some available mains that I could accidentally stick my fingers in. So if we come over to this camera again, you'll see now on the end of the power supply is this nice cover, which I just printed, got it off bushelprinters.org. Pretty sure I've stuck a link in the description for that. I definitely intended to. I'm pretty sure I did. So that's pretty neat print. Stops you getting your fingers on anything accidentally. The screws are from the side, which is not super ideal, but that's what you get. That's where the screws on the power supply are. It makes it a bit difficult to get to, but it's not something you should need to take on and off regularly. So I think that's pretty good. It's quite difficult to see in this picture because everything's really dark, but there you can see covers the end of the wires really nicely. And it's surprising how well that stuck to the end of the power supply. I was expecting it to kind of not fit, but it was absolutely perfect. So very happy with that. So we need to power on this printer. That's what we're going to do today. Well, that's the first thing we're going to do today. So I think the best way to get on with that is to rotate it this way. Yeah, that way. And then we go to mains cable and we plug it in the back. So this should do what's connected directly to mains without a switch. Nothing. So nothing should happen as long as the switch is off. I kind of want to hold plastic. So there you go, that's a pretty good start. No explosions or fireballs yet. So I think the best view for this will be about here, so that you can see if anything does go weird. What gauge wiring? It's 0.75 millimeters squared, because that's the metric way rather than American wire gauge. I believe 0.75 is 18 or 20. Can't remember which it is. I think it's 18, but I might be wrong. The cover on the wires on the extruder. Oh, that's just the standard wire cover for the Afterburner PCB mod for PCB on the Afterburner extruder. So, what's the name of the guy? H-A-R-T-K? H-A-R-K? If you look up Afterburner PC mod, you should find the GitHub page and you'll be able to find that. So, Is there anything else we need to double check? I think we're good to go. Ready, set, go. I think we're good. I hope we're good to go. Ready? I'm still in my mind like double checking that everything's sensibly wired and I've not done something stupid. No smoke. No weird noises. That looks pretty good. Well, it's a whole lot of nothing, but I think that's the best nothing we could have expected. Right? No things is good things at this point. Well, that was rather uneventful in the best possible way. What's on the display? I don't understand what you mean. On the display of what? On the here? This display? I don't know. I don't know what you mean. Anyway, I think we're good. Excellent. So I'm very happy with that. Super undramatic. Yeah. So now we can get on with doing the firmware. Now, you have to bear with me a little bit. I've done Klipper once before, and purely in order to make sure I have some idea of what I'm doing before I did this. So this might be a little bit of a bumpy road, but you're able to join me along the way and hopefully prevent me from effing things up too much. I'm fairly confident it's going to be easy. But I think that might be a bit of blind overconfidence. Yeah, there's nothing on the display. There's nothing for it to do a thing. I mean, I can do it again, but I'm pretty sure we get a whole load of nothing. Maybe we would expect it to power on if the cables. I know, because we had the cables all backwards, didn't we? I think we'll worry about that once we've got some firmware and we are kind of expecting something on the screen rather than just hoping there might be something. Right. So, firmware time. There is a bunch of links in the description down below. So I've put a bunch of new links in specifically for this episode, and they're going to be the links for downloads, for some software, for some help, for some instructions. There's kind of all the reference information that you may or may not need. Should probably need. If you're doing it the same as what I'm doing. That's basically what I'm going to be using. So there you'll have a pretty good idea of what's going on. So the plan for everything else is to basically, there's not going to be much me or printer in the rest of this episode. It's mainly going to be software, firmware configuration on the screen. So just so you know, what's the first step? What is the first step? I reckon we start with, so because we're using Klipper, point one, Klipper, hence Octoprint on the Raspberry Pi and a main board that gets controlled by this. So the first thing we're going to do is create an image for the Raspberry Pi. Now, I have already actually done this. So this actually has that on already, but I'm going to show you how to do it anyway. The only reason I did it in advance is so that I can put my own Wi-Fi password and stuff in without having to do it on a live stream. So I'll show you how that all gets done, and then we'll jump ahead for the part where it takes ages so that you don't have to watch it. Let's hope we can get this right. I need my own description. So, so the way I'm going to phrase it is as if it's a guide, because that's kind of how I'm talking, but really it's not an intense guide because I've only done it once before, so I'm not intimately familiar, just so you know. Right. So let's switch over to this. So this is the GitHub for Fluiddpi. Fluiddpi is basically like a pre-configured image for Raspberry Pi, which contains Octoprint, and I believe the other stuff, I can't remember exactly what the other stuff is you need. Here you go. Klipper, Moonraker, and Fluid pre-installed. So that's kind of all the stuff that you're going to need on the Raspberry Pi already in an image. So that's what we're going to get. So we need the image for that. So we've got this zip file here. We can just click that to download it. So that's 1 and a bit gigabytes. That's going to take a little while, and I don't really want to do that on the stream. So we're going to cancel that, and I'll show you that I already have it in my downloads, hopefully. I've lost it. Yeah, here we go. So this is basically the thing that you'll download. It's a zip file, which is your version of Fluiddpi. This particular one looks like version 1.16.2. You can see it there. And once you get that, you want to open it and extract, well, right click rather, and extract all, and then you'll have a folder with an image in it. So an image looks like that. It's a .img file. This is obviously Windows-based guide. For other things, it will look differently. Then you need to get this onto an SD card. More specifically, a micro SD card. And this will be the one that stays in your Raspberry Pi all of the time. So you want probably a decent quality one rather than something that's a little bit flaky. And you're going to have to write the image to that SD card. So let me show you how to do that. So obviously, SD card, micro SD card reader into the computer. And the software we're going to use is called Balena Etcher. If you've written images before, you're probably familiar with that software. So let's find that. Here we go. So Balena Etcher looks like that. It's a really simple piece of software. What we're going to be doing is flash from a file, selecting the USB drive, and then just flashing it. And that will basically take that image, which is the Fluiddpi Raspberry Pi image with all the stuff on it, put it on the SD card so we can put it in the Raspberry Pi. So we flash from file, we select the file that we want to use, which for me is this one on the desktop, Fluiddpi, and then that image file, and then you can click open, select the target. It should only show you the SD card, micro SD cards that you have there, rather than any main hard drives. Double check the size, make sure you're not doing this to something that has important data on. Everything does get removed, so be careful. Select your drive, and then hit flash. So this is the bit that can take a little while. You have to press yes for the user account control, Windows safety security thing. So this is going to take quite a little while to do, and as I'm streaming and I don't want it to use all my CPU, I'm going to cancel this, but you'll basically just wait until this goes all the way to green, all the way, well, it's pink actually, and it'll say it's done, and then you'll get some weird stuff come up on the screen. Once you've done that, you have to find it says actually right down here, Fluiddpi wa-supplicant.txt. So this is a text file that's on that micro SD card, so you want to remove it from the computer, put it back in, then you'll see a file list. It might give you some errors, mine does, and that's just because it's a bit weirdly formatted. I think Windows just doesn't really like it. But you should be able to find, if you go to the normal C drive location, this PC area, this kind of place, you'll find it come up in here, sort of like this. And there'll be a text file in there. In there you can put in your SSID for your network and your Wi-Fi password. That's what I've already done, so that's pretty much ready to go. That's the first bit. There you go, it kind of says, it's actually doing, so here we're going to do an SSH to the Pi now, so that's what we're going to do next. So, imagining that I've just taken, let's go back here a minute. So imagine now I've just taken basically the SD card out of the computer. This is what's been flashed, and I've modified the text file to have my Wi-Fi password. That you then put into your Raspberry Pi. You don't obviously have to have this all in the printer. You can just do this separately from the computer. You don't have to have it all in the printer. You can do it separately. Eventually, you obviously need to connect it in, but for starters, you can do it elsewhere if you need to, or via an Ethernet cable if it's in whatever location. You get the idea. Just get it. Get it plugged in and powered on. So this will boot up and get the Wi-Fi all connected. I would recommend configuring the Wi-Fi to not use DHCP and to use a static IP address. So DHCP, I believe, is a protocol that basically assigns IP addresses to things as they attempt to join a network. The downside of that is that if you don't fix it, it's different every single time. And if you're trying to access a single device multiple times over a long period of time, you don't want it changing IP address all the time. You want it to just stay as a single IP address. So you can normally do that through your router, however you like to say it, to fix a MAC address, which is like the ID of the device, to an IP address. So every time this thing joins the network, it will give it the same IP address. I've already done that, and I've forgotten what the IP address is, but we'll find it. I think it was 192.168.1.123. That is a local IP address, by the way, so you won't be able to access that IP address from outside of my home network. So don't bother trying. Here we go. Yes, this is a 300. So there will be some additional configuration I have to do in firmware, etc., etc. So if we go to second screen, so this is where we are. If we in a browser, we now need to put in the IP address for the device. So 192.168.1.123. That's my address for the Raspberry Pi, and you can see that comes up with the web interface for Fluid. Nothing's really configured yet, so nothing's going to really do a whole lot. It's all a lot of nothing at the moment, but we know that it's working, it's functional, and it turns on, so that's a good start. What we're actually going to do now is come out of here, and we're going to use a software called Putty. So Putty is a software you can use to connect to, I searched it in the start bar and it came up with something completely different. Did I not install it? I'm pretty sure I installed it. I definitely downloaded it. So again, Putty is linked in the video description, should you need it. Huh. I was 100% sure that I had downloaded it. Maybe I was wrong. Wouldn't be the first time. We could use Winscp as well. I'm going to use that later on for a slightly different setup. Well, I might as well show you this. So this is the website for Putty. I downloaded the 64-bit x86 version, and then we can install that. I've used this software for quite a few years and definitely trust it. Just FYI. Oh, I've forgotten to do me sponsor things. I'm a silly person. We should do a full sponsor spot now, because this is a sponsor video, by the way. This live stream would not have been possible without our sponsors, Fluiddpi and Big Tree Tech. Fluiddpi are a 3D printing bed specialist based in Germany. Fluidprint is their high-performance, durable print surface designed to grip parts tightly when hot, but release them when cold. Their switch system utilises a strong magnetic sticker and 0.6mm spring steel to allow for easy swapping of bed surfaces. The bed plates offered are made from cast aluminium plate and are extremely flat, helping you get the best adhesion across the whole first layer. All of this can be made to standard sizes or customised upon request. Keep on watching to find out more, or follow the links in the video description. The BigTreeTech Octopus is a 32-bit control board with loads of connectivity options for performance 3D printers like the Voron 2.4 and RapRig VCore 3. It can connect up to 8 stepper drivers, 8 fans, 6 end stops, 5 thermistors, 4 heaters plus BL Touch, RGB LEDs, a TFT screen, USB-C and more. Pairing the Octopus with TMC 2209 stepper motor drivers allows for quiet operation using Stealth Chop, performance using Spread Cycle and Stool Guard for sensorless homing. BigTreeTech also offer a mini 12864 display, which is ideal for the Voron 2.4 design. Check the links in the description to find out more. So, unfortunately this is quite tiny and it's not super easy to make it bigger. I suppose I can sort of drag this. No. Yeah, not very easy. Hopefully you can see that enough. This is the window for Putty. So Putty is a thing that uses SSH, which is like a communication, is that a protocol or another type of thing? It's a way to communicate over a network between devices. So we're going to connect via SSH to our Raspberry Pi. So to do that, first we're going to, this is just the window it opens on. We're going to input the IP address, 1.2.1.2.3, and we also want to save this as a configuration. We're going to call it, what should we call it? Voron 2.4 300. It's not a very creative name, but it'll do. So that gives us a quick way to reconnect at another time. We can actually put in, you can put in passwords and stuff for this as well. So in this case, as always for Raspberry Pi, the default username and password is login as, the login is Pi and the password is Raspberry, and I typed it wrong, so it's not going to work. There we go. So if we look on the Fluid page, it actually gave us some recommendations of things to run in basically getting everything up to date. So I guess these things are sort of optional, but best practice and quite easy to do. So I think we can just copy from here. Hopefully this won't take too long. So this is going to update everything on here. Hopefully it's going to be quite quick. There shouldn't be large amounts of data. These update files are normally smallish, so hopefully not going to interfere with the stream. If it does cut out while I'm doing this, then you know why. I'm not sure what this is talking about. Hopefully not a problem. But when this comes back up again, you know that it's done what it was doing. So we'll do the next command as well. You just right click, you don't have to paste. Right click just immediately pastes. After this operation, yeah, let's go ahead with that. Again, this is presumably an upgrade process, making sure everything is up to date. So I would recommend you change your password and your localization options, hostname if you want to. I'm not going to do it on the live stream because obviously I don't want everyone to see whatever password I do put in. I mean, I'm pretty sure it comes up as stars anyway, but I'm just going to skip over it because reasons. Hopefully this will be done imminently. That's 61 fetched. doing a thing. Just waiting for it to do the computery things it's doing. I suppose in the meantime we can start taking a look at the next steps. So I think next step for me is to, I mean it's going to give you some options here, the reboot, Fluiddpi available there, and will present an error about a missing printer config file. Please ensure your printer config file is configured correctly for Fluid. See the Fluid docs here. Once this is complete, you can now progress with your standard printer setup. So printer config is basically the information about your printer that you need to input. Normally, or if you were creating your own printer completely from scratch and there were no configurations already available or nobody had made one similar, then you'd have to start pretty much from scratch, which is not like the end of the world, but it's easier to start from something and adapt it than depending how close it is. It's generally easier to start from something close and modify it. Excuse me. Fortunately, Big Tree Tech has already provided printer configuration stuff on their GitHub page. So if you go to link in the description, Octopus works on Voron version 2.4. This is all sorts of stuff that you can use. So we've got firmware in here. This is how you plug it in. This is we looked at actually earlier in another stream, you'll have noticed, where we were wiring stuff in, because where you plug it in is obviously important for the firmware configuration. They've actually got a config here for RepRap firmware as well, which is rather nice. But that's not what we're going to be using. This looks like a PDF of the same document. Yes, we don't need that. What we need is Klipper. So it's important to read the instructions. As always, things could be updated or changed, especially if you are using a different board in the future, rather than this exact same one. Comes with the bootloader, which allows firmware to update through the SD card. We recommend using SD card to update the firmware instead of DFU. DFU is like a way that you can do it. Did it say here? No, but it's a way you can basically update the firmware through the Raspberry Pi. If you have ever used DFU to upload firmware, you can use the instructions here. So we've got Big Tree Tech's Octopus Voron 2 config. It's the reference configuration file for Voron 2.4, which is what it asked for in the Fluid thing, that printer.cfg. You can modify your own configuration file based on this. Note, no position max of XYZ set. We offer these sizes. You must select one. So that's pretty easy. It gives you also some suggestions for wiring stuff together. I've not used this. I've gone for this option. So we're powering, powering the Raspberry Pi via USB-C and then connecting again via USB-C to the Big Tree Tech board. You could do this if you wanted to. So this is what we've got to get onto next, I think, once this is sort of regretting doing this now. Should have just done this afterwards. Boop, ba-doop, ba-doo, doo, 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 doo. So you have to generate the firmware.bin file. I'm not sure what these two are for exactly, but I'm not going to worry about that too much. We'll have a look at this. So the config file, if you're familiar with Marlin, or have seen or used Marlin before, then a lot of this, it's not the same at all, but it's the same kind of methods that you're using to configure it. It's like text-based firmware configuration. So you're configuring your Y stepper, your pin, direction, enable, microsteps, This is all your pin locations, distance, rotation, so that's like steps per millimeter kind of stuff. PIDs, temperatures, all the kind of stuff that you expect to find in a configuration file. Should have done this part in a separate video. It is a separate video. That's why I'm doing this as its own live stream. Oh, I should have done, here we go, it's just done, excellent. So, where were we? Klipper. Got 2 bin files here, but it does suggest creating your own. Precompiled firmware, the source code, Firmware USB. Use USB to communicate with Raspberry Pi. Connect the type A USB of Raspberry Pi with USB-C of the motherboard, Use USART2 to communicate with the Raspberry Pi. Connect the UART-TX of Raspberry Pi, So this is not really a 1 or 2 as far as I'm aware. This is a... This is odd. Use USB to communicate with Raspberry Pi. Okay, so this is like pre-compiled. We could just use this one, or we can create our own. I guess there's nothing special. This will just be use USB, so they've done this configuration as one file, and this configuration is the other file, looks like. So I think we're probably safe to just go ahead and use this bin file. So we'll download that. And this is what's going to be going into the BigTreeTech Octopus. Maybe I should show you how I've done that. For demonstration purposes, let's go configure our own, because that sounds more fun. So, especially for people that don't have the advantage of having them pre-made. Luckily, all the kind of steps are included here. But, as you can see, the official installation, which is actually a link I've already got here, and is linked in the description, so if you want to know how to just follow the instructions, you can do that too. So if you're following installation, we've already done prepping the OS image. For us, that was the Fluid installation, and then we're building and flashing the microcontroller, and this is where you're creating your bin file. But instead of completely following the guide, we're going to stop when it says flash the thing. We're just going to create the bin file and then copy it off. So again, it's going to give us all the commands that we need. We just have to copy them and type them in. That changes directory, that's what CD is, that's anywhere, Klipper. So changing to that directory. And then we use this to launch the configuration menu. Very, very nice. And as we can see in the BigTreeTech Octopus, this gives you information on how to do it. If you're using something that doesn't have all this information nicely available, I would suggest going to the following location. Go to the, come on Adam, Klipper GitHub. On the Klipper GitHub, there is configs. So the configs are examples of printers, but also examples for control boards. And if you go onto one of these, there's all these instructions in here that you should read. So this would be a base configuration for this control board, but wouldn't be set up specifically for this printer. So if you were going to use this, it would be an okay starting point in terms of the pins especially, but steps per millimeter and all that kind of stuff, the printer size, whether it's Core XY, they're not going to be in here. So it's not complete, but it could be a good starting point if you don't have the advantage of pre-made firmware. There are lots of other comments typically in this file other than this. So here you go. That's talking about what stuff's available. So it's normally good to have a good scroll through one of these that's for your control board just to check that you don't miss anything. The one that I did previously had quite a lot of instructions in there that I didn't end up finding until I'd spent like an hour and a half trying to diagnose a problem. So I recommend looking at that. Even if you think you're not going to need it, I would check it anyway. There's loads of control boards in here, so chances are it does exist. So we're going to be following the Big Tree Tech instructions because that should be the easiest way for us to do it. So, microcontroller architecture, STM32, processor model, STM32F446, this one here, bootloader offset, 32 kilobits, that one we don't need to change, clock reference is 12 megahertz crystal, communications interface, and we're going to be using USB-C. That's because we're connected via the hang on, let's just, can we do, no. We're using USB-C just so that's what this cable out the board over here is for. If instead of using this, you're using these pins here to the GPIO pins, then you'll probably be using, I believe it's SPI, right, or UART. What's the other, UART or USART2? That's the alternative method. I'm going to be going with USB. I think it's just a lot easier to wire up. What parts from the config examples should you take from the board config examples, and what parts from the printer config examples? That's quite a good question. So things like your sizes and steps per millimeter, things that you could change in your design, they're going to be things that are properties about your printer you should take from the printer config file. Things that are properties about the control board, like the pinouts. Like normally your pinouts on your board will be labeled, and so those labels will be associated with those numbers in those pins. If you plug something in a different place, that could be something to look at in terms of changing pins versus a default setup. But yeah, it's normally pins from the board and sizes and steps and heaters and such from everywhere else. Cool. Enjoy your maths revision. Hopefully it goes well. So, comms interface, USB. I don't think we need to do this bit. I'm not sure what that is. I don't know, so I'm just going to ignore it. That's always the best policy. Don't need to do that. I think that's all we need to do, right? Community interface, the port you want, serial, USB, Mine looks the same as that, so we're good to go. So we'll press Q to quit and yes to save. So that hasn't actually made the file yet, and it's quite easy to think that it's done it when actually it hasn't. So now you have to do the make command, and that actually makes the thing that you want it to make. Yeah, it probably says in here. Yeah, so menu configs here, select options, and then make. So you just type in make. And that's going to use those configure options that you just spent probably hours sorting out, and then makes the bin file that you need to put onto your control board. And that's basically making the firmware for your control board. Because obviously the firmware on the control board is a little bit different to normal. It's mostly just communications because all the bulk of the stuff's being done on the Raspberry Pi. We can zoom this in, I think, can't we? No, we can't. Normally control scroll will zoom in, but in this case it doth not. So I'm going to, what are we going to do? So there's two things we kind of need to do now. Well, first we need to grab that bin file, and that's going to use a different software, and we need to find the ID, the USB serial ID. So, I don't know, let's give this a go. So this command is basically, so ls is list, so it's going to be listing in the serial port connections by ID. Hopefully it's kind of fairly self-explanatory. It's going to be listing the current connections. And there you can see. Dev serial USB Big Tree Tech Octopus. That's a lot longer than I was expecting, but that looks like what we need. So I'm going to, can we copy that? I thought we can copy it. Now it's just pasting. Stop pasting. I'm just trying to create a new note. I'm not sure if this changes later on, so I'm just going to type, I'll paste that in there, so we've got it for later. That's the serial location of the USB device. Selecting is copying, yeah. It's weird with these terminals, like right-click pastes, and because they don't, you use Control-C to like end commands, is sort of just different. But it's fine. Just selecting does the copying, which is fine. So now we're going to grab that bin file off of here. So we can close this session, and we're going to start Winscp. There are definitely other ways to do this, but here we go. Winscp is another software, a little bit like Putty, but it gives you a bit more of a user interface. So if you're doing some file management, like we're going to be doing here, it's just useful to have something where you've got a bit more user interface, and rather than just entirely text-based. So the host name is the IP address, 192.168.1.123. Your username, as always, Pi, and the password is Raspberry. We could save that. Again, just another way to quickly connect. So this is like the license thing. You can just say accept because it's our own thing. For some reason, it asks for the password again. But once you're connected, this is now on the right, the files for your Raspberry Pi, and on the left is the files on your computer. I'm going to go to desktop because it makes it a little bit easier to work with. So if we look on the Big Tree Tech instructions or the Klipper instructions, the Big Tree Tech one's probably a bit easier here. When we've done make, the clipper.bin file is generated in the folder home pi, well, Klipper out after make. So if you look here, we're already in the directory home and pi, so we just need clipper/out. So clipper out, and here we are. So the Klipper bin file is what we want, and we're just going to click that and drag it over here to the desktop. I mean, you could drag it into here or down to here, it doesn't really make a difference. Okay, so that's transferred that bin file right there. That now needs to go onto a micro SD card, which will be remaining in the Big Tree Tech Octopus. So yes, getting the serial. I thought that would be the case. So the comment there, I can't, Zinim, whatever the name is, to apologise. That USB serial port that we got from that list command, that changes when you change the firmware on the control board. So normally, if you're following the normal instructions and you're flashing through the Raspberry Pi instance, through Raspberry Pi, you need that in order to do the flash. But we're going to be using USB instead, so we don't have to worry about it. It will think it's a link if there's a dot with a full stop with no space on either side. FYI. I believe you have to rename the firmware file to firmware.bin. kind of says here, but you have to rename it to firmware.bin. But we'll get it on the USB drive first. So we don't actually need this now. This session can go. We can have a hello. Oh, I think I might have upset that micro SD card by cancelling the when we did the flash earlier for that image file. I might have made a mess of it. So we've got 8 GB micro SD card, and we're going to grab that file from the desktop, clipper.bin, copy and paste into here, and we're going to rename it to firmware.bin. Because this is what the control board is going to look for as it boots up to check if there's a new firmware to install. So if you don't rename it, then it won't see it. Here you go, it tells you here. To the root directory, insert the SD card, press the reset button or restart the power supply, the motherboard will automatically update. So take that out, micro SD card into here. Unfortunately, we're going to have to undo that because we've got a right angle USB-C port. Stick that doobly in there, put that doobly back in there. That looks like a restart button, although I don't know. I have no idea if that did anything. We'll give it a minute. You can't see it. So micro SD card in the top, that should be all the way. It looks like it's sticking out a lot, but it is all the way in. I think this is a restart button. That's what I've pressed right up in the corner here, but I could be wrong. I was expecting to see a whole lot of flashing and stuff. Let's try the old turn it all off and turn it back on again. I'm kind of expecting something to be flashing while it's doing a firmware update, but maybe we won't get that. If it's the same as the other board, then it does actually change the file on there when it's happy that it's done it. So there's nothing flashing to suggest that it's doing something. Let's have a little look. Can I get this out? I don't think I can. No, that's annoying. Let's have a little look on here just to see if it's worked. I guess we could probably check Klipper as well. Yeah, it's so this is the same SD card, and you say it now says firmware.car, which means basically current, so current firmware file. So that means the update has worked successfully. Happy days, eh? I'm not actually sure if we need that in there or not, but I'm going to leave it in there for now. So things are looking pretty good. If we go back over to, oh dear. I can't type. There we go. So we're missing this printer config file now. So doing pretty good, I think. I need a drink because this is intense. I'm doing a lot of talking. It's a very talky based episode, this one. I think we're making pretty good progress though. Not had any major dramas so far. This is where things start to get a little bit more difficult for me because I've never seen or used Fluid before. So if I spend 2 minutes clicking around an interface looking for something, that's why. So what we need now is some way to tell the printer about the configuration, well, to tell the Raspberry Pi rather, the configuration of what the printer is, and that's the file that we want from Big Tree Tech. So this is this file up here, bigtreetech.octopus. For some reason, P is capital, no idea why. And that's this file. So we're going to press raw and that will download. Oh, come on, can't we just, can we save link as desktop? Oh, let's grab that to somewhere easy to see. Oh, come on, I just want to put it there. Where is it? Here we go. So now we have this config file, but it's not going to work as it is. We do need to rename it. So Fluid, as you can see, is looking for a specific file when it wants config. It's looking for printer.cfg. Ooh, super zoomed in. Printer.cfg, no capitalization. So that's what we're going to rename this to. printr.cfg. Now hopefully there's a really easy way to just upload this file. Can we just, oh, look at that. Boom. Hopefully that's in the right place. It doesn't need to be over here. I have no idea where it's supposed to be. Config examples, docs, logs, other files, configuration file. It is a configuration file, so that should be right. Oh my days. This is not quite what I was expecting. Why does this look like this? That's not what I want. That has not done what I wanted it to do. Because this is the page rather than the file, isn't it? Yes. Yeah, that's an HTML of the web page rather than the actual file. So let's get rid of that. That did not work. Config. Text. Okay, hopefully this will be better. Oh, I lost all my windows. So yeah, right-clicking Save As I think is going to be the better option. If we view that in Notepad, there you go. That looks like the config file rather than just a massive HTML page. So this is what we need to then rename. Config.cfg, delete, 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 delete. Oh no, it's printer.cfg, wasn't it? It will warn you about changing the file extension, but don't worry about it, just press accept. Okay, let's have another go at this. Printer.cfg. Hopefully if we edit that now, this is much more like it. So this is actually where we need to get that thing from. This is going to be much more important. I'm going to do a restart now. Once analyzed, use the restart command to reload the config and restart the host software. So I guess we can just use these. There we go. There we go. Max position. So now it's giving us configuration issues, which is much better. Everyone's telling me 10 ways to save the file. Yeah, yeah. Thank you. So this is looking a little bit better. This is starting to look like firmware. Obviously we've got an issue that we need to fix. Let's go have a look. So this is where it's probably going to let a little bit hit and miss. This feels quite like, what's the duet web control. So this is the thing that we need to make sure it can communicate with the control board properly. So I'm going to, there might be a better way to do this. I'm going to use Putty again, and I'm going to go follow the previous steps that I did. So using this, we've got this saved here, so we can connect just by double clicking. Log in as the same. It's saved all the commands from before. I don't think we need to go to Klipper first. So there we go, now we have this. So just highlight and then let go, and that should copy. And then we do this and we paste it in here. And I can't paste. Why can I not paste? Hello? Okay, Control V, we can't right click to paste. That's fine. Was that the same? I think it's exactly the same. That's probably a good thing. So, if we start just having a look down here for things that don't look quite right, we can fix them as we go. Oh look, it actually says obtain definition by ls-l, and then unplug to verify. Very nice. Let's just do that. Clippy not connected. So is Clippy what's on the control board? Have we not got that quite right then? Let's go have another look. There we go. Very similar, but not the same. Save and restart. I'm going to assume I've done something incorrect there. What have I missed? I think we might have to turn the whole doobly off and on again. Let's try a full off and on. Oh, do I have to get the... Obviously, it's giving me errors about the size. I assumed I could get this connection working first and then do that, but maybe it's going to give us warnings and not allow anything else until we've fixed all the warnings. So let's fix those first. So we know this is designed for Voron 2.4, so I'm going to assume everything to do with steps per millimeter and heaters and all this kind of stuff is all correct. I'm not going to really check them now because I've basically used the default bill of materials, mostly, to the point where I shouldn't need to configure any of that stuff. I'm just going to check that stuff is there. And I've immediately just noticed this, actually. How many steps per rotation? 0.9 degrees we do for X and Y. So we need to set these to 400. The step X. We need to set this to 400. Uncomment for two. Oh, here we go. This is where we need to do the uncommenting stuff as well, isn't it? Oh, it gives you a nice list of things to change and check. It's unfortunate that this is going to be, I know. Oh, by the way, that's the thing. So let's create a new screen snip. Oh. Just going to snip that so I can check it off screen. So the MCU path is this. That's the first thing we've done. Check that one off the list. We can literally check it off the list. Bush. Next. Thermistor types, that's not going to be here. So I'm going to comment for 250, 300. So comment's going to be this thing here. So, I mean, I don't know why they put 2 on some of them. So we need to remove this one and this one. That's for 300. Update below for relevant driver. We are 2209, so that should be okay. And then we've got to do this again. Z's are 1.8 degrees. Z position of nozzle to Z end stop trigger point relative to the print surface. Increasing precision end stop brings closer to the after you round Z end stop color weight. Position end stop will be stored at the very end of your config. Okie low for 300 build, so that's another one we can get rid of. Not get rid of, uncomment. So you could do both, it's just not going to make a difference to this line because it already has to. Make sure to update below for your relevant driver. Yep, we are 2209. Z1 stepper, rear left. Make sure to update Z1, Z2. Z2, Z3, Z3. E0 on motor 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes, that's right. Is it? Oh, 0, 1, 2, 3, 4, 5, 6. Of course it is. Yep. Extruder, update value below when you perform extruder calibration. Yeah, of course. $22.6 is a good starting point for Bontech 5mm drive gears. That's what we have, so we're good there. Do we have a 0.9 degree motor for? I think we might. I can't see. No poop. I don't know if it's a 0.9 degree stepper motor or not. Give me a minute. $1.8. So 200 for 1.8, filament diameter, heater pin, validate the following thermistor type to make sure it's correct. Semitech 104 GT, that's the standard E3D one, isn't it? And that is what we're using, so that should be okay. Min temp 10, max temp 270, max power 100%. PID, obviously we'll need to do that at some point. Default pressure ounce is 4. Let me just make a note of things because there's so much stuff to configure, isn't there, that I'm going to forget. PID. Pressure advance. We will do the accelerometer's input shaping. That won't be today though. I'm thinking at the moment we might do the first print on one episode and then the one after, like after the kind of official series has ended. We'll do some additional calibration stuff. I think that might be a good way to do it. E0 on motors. That's okay. I mean, these stealth chop thresholds at 0 will mean that everything's always running at stealth chop, I believe, but I'm not sure. This, I believe, is the right thermistor, so we should be okay there. Adjust the max power so your heater doesn't warp your bed. 0.6, interesting. So it's only going to be running at 360 watts. That's bizarre. I'm going to increase that a bit to at least 80%. Min temp 0, max temp 120. That sounds a bit generous. And we'll need to do PID for that too. The probe is not used for Z-height, only quad gantry leveling. So position should be okay, sample should be okay. The Z offset was probably going to be problematic. I wouldn't be surprised if we... 0 was always spread cycle, okay. Yeah, 0 on the Z offset. I'm imagining at some point during this configuration I'm going to smash the nozzle into the bed because I'm not familiar enough to get it right first time. Fan, printing cooling fan, that looks normal. Heater fan, these should all be in the correct ports anyway. Fan controller fan, very nice. So, we do have an additional fan, don't we? So CNC fan 0, PA8, kickstart time 0.5, off below 0.1. Heater fan hot end, print cooling fan, print fan PF, yeah. So the hot end fan is that one, and then heater fan controller. Yeah, so that's the one going out there. And then 3 heater fan controller is another one. Why have we plugged it in with a gap? We're missing a fan. Is that exhaust? P12. Let's check the Big Tree Tech pin diagram. This is very large, isn't it? Well, that's not quite what we want. J52, that's not the kind of pin numbering I'm hoping for. Is it? That's not what's used in the firmware configuration. No. I would like a pinout diagram. Oh, not from a weird website. Where's the GitHub? Oh, I was already there, wasn't I? Fool. Have it in English. Might be a bit easier for me to read. Power. Raspberry Pi, Pro port, step, SPI, fan, and proximity switch 15. I'm not expecting to find them here. Where's this pinout diagram? I bet everyone's yelling at me at the comments, aren't they? This is an enormous PNG. That's not what we want either. That's 3D ones. Is it in here? Aha. No. Configs. Pinout. No, that's the one we just used. Which doesn't give you, it gives you like J51 and J52, which is not really what we want. Is it on the side? Hardware folder. Yeah, I know what it looks like that I'm looking for. Yes, this is the one, isn't it? Right. Although that's not the best format, is it? Is there a better? No, that's size. Maybe this is going to be the best one. And this is all using J numbers as well. Oh, here we go. This stuff down here. This looks better, is it? J51. It's still using J numbers. Why is this completely different to what's in the firmware? This is concerning. This is saying P88, PE5, PD12 for these, and yet their own pinout diagram tells me differently. This is confused, isn't it? It had the right numbers. What, the image or the firmware? Because that means their firmware that's literally by Brigtree Tech for their Voron is not correct. Because that is not pin PE5, is it? Am I just being blind? Is that what you're telling me? This is diag pins. Fan 7. I agree, it looks like the whole connector. Fan 6 plus. Fan 7 plus. Is there a different diagram that's telling me where fan 7 plus? What fan 7 plus relates to? Boxes have PD12. Oh, yes, there we go. How did I not see that? I'm blind. Wow. How did... Bizarre, 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 bizarre. Okay. Alrighty then. So 8, PA8, PE5, PD12, PD13 is the next one. Excellent. So I'm going to uncomment this. And I also want another one. So this exhaust fan is our skirt fan, basically. And I want 2 of those. This is going to be number 4. And the next one is PD. Exhaust uses PD13. Those are 1, 2, 3, 4. Tell you what, I'm going to put these 2 together. Exhaust is going to go after it. So exhaust is going to be 1, 2, 3, 4, 5, which is 1, 2, 3, 4, 5, which is going to be PD14. And then this is going to be, oh no, exhaust is, Jesus Christ. This is not what I thought it was. This is the exhaust for the filter. There's not one on here for, oh, it's this one, isn't it? This is the one I want. Copy that one. So we've got 0, 1, 0, 1, 2 and 3 are going to be heater fan. No, it's not. Print cooling, hot end, controller fan. Yeah, controller fan, controller fan, controller fan. 3, 4. 0, 1, 2 and 3. It can be easier if I put that in here. 0, 1, 2, 3 and 4. This is going to be PD13. There we go. So when the bed, I'm not sure why the bed temperature is relevant. I suppose that's whenever the bed is on and warm, the fans kick in for the lower chamber. That seems reasonably sensible. Ah, yes. Right, this is the name then, apparently. Fan, heater fan, hot end fan. Heater fan, controller fan, heater fan, controller fan 2, and heater fan, exhaust fan. Oh, I do have some LEDs. We're not going to worry about LEDs today. LEDs will get installed when we do enclosure, which will be maybe next episode. Homing and gantry adjustment. Z safe home. XY location of the Z end stop switch. Update -10 to the XY coordinates of your end stop pin. Well, that's not going to be easy, is it? We're going to not get that yet. I'm not sure, why is quad gantry all uncommented? And display, we do have this, where is it? 12864. So that should enable our display. And then we've got some macros here too. Oh, thermistor types, useful. Okie dokie. Voron dock site has an initial startup. Initial startup might be what we need right about now. Save and restart. Often points in quad gantry level must be specified. So how long have we been going? And how many sponsor spots have I done? Only one. I think it's time for a quick sponsor segment. This live stream would not have been possible without our sponsors, Fluiddpi and Bigtree Tech. Fluiddpi are a 3D printing bed specialist based in Germany. Fluiddprint is their high-performance, durable print surface designed to grip parts tightly when hot, but release them when cold. Their switch system utilises a strong magnetic sticker and 0.6mm spring steel to allow for easy swapping of bed surfaces. The bed plates offered are made from cast aluminium plate and are extremely flat, helping you get the best adhesion across the whole first layer. All of this can be made to standard sizes or customised upon request. Keep on watching to find out more, or follow the links in the video description. The Bigtree Tech Octopus is a 32-bit control board with loads of connectivity options for performance 3D printers like the Voron 2.4 and RapRig VCore 3. It can connect up to 8 stepper drivers, 8 fans, 6 end stops, 5 thermistors, 4 heaters plus BL Touch, RGB LEDs, a TFT screen, USB-C and more. Pairing the Octopus with TMC 2209 stepper motor drivers allows for quiet operation using Stealth Chop, performance using Spread Cycle and Stool Guard for sensorless homing. Bigtree Tech also offer a mini 12864 display, which is ideal for the Voron 2.4 design. Check the links in the description to find out more. I am trying to read chat as I go, I do promise. I'm just not reading it out loud like I often do. And I think there seems to be a really big delay today. I've noticed that. So you may notice this too. So I have noticed that message about NeoPixel, so I can go do that. I was just looking while you were watching that small advert about there we go. Because there was a comment about the initial startup section that includes ZDOP pin location, but I can't find that website or folder location. So I went to here and I assumed when you said Voron docs, you meant this, but this is just assembly manual. Is there a different thing? docs.vorondesign.com. Okay, let's try that. Ah, a special website that they don't link to. Okie dokie. Right. Here we go. Some information. Not seen this before. Build. Initial startup. This looks useful. Okay, this is all well and good, but I'm still getting this error message. Quantity low option points for the quad gantry level. So 250. Oh, they are here. I don't have to work them out. That's nice. Yes! Oh. What's this? Fluid warnings found. Virtual _ SD card not found in printer configuration. Pause resume not found in printer configuration. Cancel print macro not found in configuration. Okay, that sounds like things that it's recommending but are not immediately a problem. So, where's the console? Is there a console here? Is there one at the top? Loading tool, macros. Oh, console here. So, yep. And we've got this over here. So now we can run through these steps to give us a good idea of what the dickens is going on. So, I believe we probably want to, oh, well, the display is on, so that's good. I think we need to turn the printer around. So I'm going to turn it off, move it around, and then turn it back on again. Let's give you a shot of what the hell's going on. Oh. So we probably want a normal front-facing sort of arrangement to watch the drama of things crashing about to unfold. Of course, that's turned off so that it is connected. Ah, shut down properly. Raspberry Pi doesn't mind. Maybe it does. It hasn't turned back on again. It was all fine. What did you do? There we go. Are you talking about this emergency stop button? Restart firmware. But I don't want to restart it. I wanted to turn it off. But yeah. So in the console down here, let's have a go with these stepper motor buzzing commands. So we have X. So let's make this in the middle so that if anything weird does happen, we have some space. Well, it's one of the motors, so that's fine. Do the same for Y, which is going to be tether motor. I love how it calls it buzzing. Host shutdown. Okay, I shall do it next time. We have like no belt tension at the moment. Z1. Z2. Oh, need to wait a bit. I think the manual give an indication, doesn't it, of which motors are which corner. So the manual says Z0, 1, 2, 3, and that's what we seem to have achieved so far, so this is good. Last one is Z3. Looking good. I'm going to do a small bit of belt tension here. Maybe not final, but just so we get something that's not going to be so slack that it doesn't move properly. I'm sure there's a proper way to do it, but this will do for the moment, just so we get the motion that we expect. So the command will move motor up and down. If the motors do not move or make strange noises, check the wiring. Extruder is the other one we need to do. I mean, it's kind of making a high-pitched noise, but I think that's actually correct. It does seem to be moving rather than just beeping. Oh, tells you the motor positions here. I should have just paid attention, shouldn't I? This looks very different. Is this like an old version? Got handles and everything. End stop check. Make sure that none of the X, Y, or Z end stops are being pressed. Then send a query end stops command. The terminal window should respond with the following. I can't. It's all covered up because of this. X open, Y open, Z open. That looks good. If any of them say triggered, double check. Next menu, press the X end stop and query end stops. So this is X triggered. Ah, that says Y triggered. So this will probably say X triggered. That says X triggered. So we probably need to swap those around. And Z. Z's fine. So we do need to go and do that. Oh, I'm going to shut it down to just going to flip the printer on its back so we can switch around that end stop wire. Where is it? Here. Oh yeah, yeah, it could have just been done in config. Yep, that's absolutely true. Well, you know what it's like. This is the way I've done it. At this point, everything is ready to home X and Y. Oh, false refresh. Important. You need to be able to quickly stop the printer in case something goes wrong, e.g. the toolhead goes the wrong direction. There are a few ways of doing this. Use the e-stop button on the display if installed. On the Mini 12864, it is the small button underneath the main control knob. This one here. Test the button and see what happens. Klipper should shut down. Raspberry Pi and Octoprint should still be running, but disconnect from Klipper. Oh, can barely press it. Did anything happen? Yep. Press connect in the upper left corner, then the Octoprint Then in Octoprint terminal, send firmware restart to get printer back up and running. Firmware restart. Hello 3D HP. So it is. Yep. Display is all working. Probably want a different color, but I really don't care at the moment. That's a good start that it's doing as I'm expecting. Have a computer right next to the printer with the restart or M112 command already in the terminal command line. When you start homing the printer, if it goes in the wrong direction, quickly send the restart command, it will stop the printer. What's the chances of this going completely balls up? Well, that restart command did not work. That was absolutely terrible. That's weird. Homed X and it just moved in Y. Don't you just love it? It said you can do either. That's clearly rubbish, wasn't it? Yeah. If I'd have thought about it more, I'd have realised that restart is not a G-code. These things were expected to happen. Everything seems to be okay. Oh, I turned it off. I'm going to leave the belts a bit loose for now because it helps them skip when I crash into things. Okie dokie, some nice diagrams here. So this one. Is that turning back on? It should be. You can invert the direction of a stepper by turning its connector 180 degrees or toggling the inverted flag for the stepper in the firmware. The arrows indicate the positive direction for move commands. Swap the A and the B connectors for the motor. Oh, which involves turning it off again. I'm just going to do it mechanically rather than firmware. So motor, Switch them around. I think this is the most fun way we're doing it. It's all right. Nothing's going to break. It's okay. So I really want it all the way up, although in the middle, because it's probably going to go the wrong way. What the actual? That was doing all kinds of weird stuff. One of the Z is back. Why are all these configurations so balls up mess? Everything's plugged in exactly as it should be, so why are they going in the wrong direction? 0, 1, 2, 3. From right. To me it sounded like this one back here. Can we not just do a fucking... I don't want to do a home. I would never start with homing. That's just the worst thing. We need to check the fripping directions are going in the right way before we start trying to home stuff. But for some reason it's like, oh yeah, just go and home it. What? I would just rather have a move command. Just ignore end stops and do a move. So we know that move is going in the right direction. I suppose that's what this was supposed to be. So up and then down, what the hell is that supposed to mean? Is that positive and then negative? So that's going up first. That's gone down first, so that one's wrong. Where's the config file? How do we get back to the config file? X, Y, Y, Z. Z1. So this one, direction pin, nothing, 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 nothing. Interesting. So why is this one going in the other flipping direction? Is a direction pin that you have to put it in front of, or yeah, that would make sense. Yeah, forcing 5mm move is what I would normally do, I'll be honest. This one's also wrong. do them all first. That was also wrong. So the only one that was correct was this one in front of me. Up, down, up, down. Right. 0, 1, 2, 3, and so 2 and 3 need to be swapped. X, Y, Z, Z, Z1, Z2, for some reason is already swapped. No thank you. Z3, swap. Save and restart. Even these need to be inverted, homing X should not move Z at all. Did I press the wrong button? Did I accidentally press home all? No. But they should all go in the right direction. So let's try the X and Y. So they're going positive first. So positive would be 0, 0 is normally front left. So positive is that way. So we're homing to maximum. Yep, X direction is okay. Although difficult to tell because it's not A and B, it's X and Y. Z should move up first, especially by other firmware standards. It should move up 5mm or 10mm before doing anything. And if in this firmware it's like 15, then that would explain why the whole thing went a bit tits up. Okay, let's try this 112 again. I'm going to use this instead. I think it's going to be easier to press. That's now doing the other direction. So even after I switched the motors, it's still doing it wrong. I can see why this might be painful to watch. It is my first time doing fluid and configuration like this. The other printer that I did was actually much easier because I did the whole firmware configuration myself, so I knew it was right before setting it up. This is one of the downsides, I think, of having pre-made firmware, is you have to check everything anyway, so you might as well just do it your bloody self. Well, at least we didn't overcommit the promises of today, isn't there? Positive X, positive Y. Let's check what they're doing. Config, print config, edit. Printer, step X. So directions inverted on X and directions inverted on Y. It's too much to read right now. So even after I swap the motors around, they're still... I think we should invert A and B rather than swapping the connectors. Or uninvert them, I should say. I'm not sure if this is going to be correct, but we'll try it. Oh, Florian, it's just removed all your messages. I'm sorry. Refrain from posting links. Yeah, there wasn't even a dot in it. I don't know, sorry. Oh, did you say .config? Yeah, printer.config, then yeah, that's why. If you have a full stop, period, whatever you want to call it, without a space on the right hand side of it, then it thinks it's a link. Oh, I already did this, didn't I? I changed it. Lost connection with MCU. Why? Why is there no MCU connection? It is on. It should be the running. This is not good. Oh, okay, yeah, I've got this. I need to invert step A. Yeah, I read it wrong. Are we here? Don't have anything. Have I just broken the whole thing now? Right, okay. Where are we looking? Config. B is X, so we want to put that back to inverted. I have to save and restart again. Oh, Looks like thermistor's working, which is a good start. Okay, so let's try this again. 112. Oh no, we're going to use this button. It's a bit easier, isn't it? Because I can look at it when I press it. Home X. Oh, god damn it! So, don't you just love this? Can I do this before? Looks like it. Maybe I do need this one. Or maybe I inverted the wrong one. If they're both inverted, X is going to the left. So I need to invert both. So I take them off of that one and add it to this one. Oh, it's too late. Well, according to this, if the only option where X is on the correct axis but the wrong direction is invert both, right? I suppose it could be this, in which case, yeah, okay. Yay, Core XY! Right, we'll try the home X and Y this time, so we can... Oh, I've balked it again. Oh no. So add force move. Do I just add it anywhere at the bottom? History, tune, config, printer, edit. Where do I add force move? Do I need to add it for all the steppers, or can I just chuck it at the bottom? I'm not familiar enough with how I would do that. Yes, at the bottom. Okay, but it looks like I still need to... Oh man! I think things were going quite smoothly until this point, weren't they? I thought I was doing all right. We're 2 hours in now. Right, that should be coming back on. Okie dokie. So now we have force move, so I should be able to do... Why does it still want me to home? Do I have to do something else first? Oh, I have to set position. Okay, so that's forced it to basically home in its current position. Nope, still don't like it. Unknown command, second immediate. Yes, it did. Yeah, I didn't read that. So did it not do this firmware change? That's in there. Oh, do I have to put... Oh, goodness me. Enable force smooth. Oh yeah, of course, it needs to be the other way around. Yep. Don't you just laugh how, like, how backwards this is going? It's just silky smooth operations. That's what this is. Oh dear. Can you feel the pain? I can feel the pain. Yes! Okay, we're there. X is going in the right direction. Does it have to be? Y is going in the wrong direction. So X to the right is good, but Y is going here. So we need to now swap both A and B. This is the real Voron experience, damn right. There's no fakery going on here. You're getting everything. Swap the connectors, but can I just not switch direction of both motors? No, because that's going to change. Oh, I was looking at the wrong image. Voron 2. X in the right direction, Y in the wrong direction. Is this image here, isn't it? This is, yes. So why, when I've wired everything exactly as it's meant to be, do I have to put the connectors in the wrong plugs? Oh. Changing pins isn't needed anymore. Apparently. Yeah, I suppose I can just switch the pins over. That's it's absolutely true, yes. But that's, yeah, you're just redirecting the firmware to look at the other connector. Have I not turned it back on? I've not even plugged it in. Oh, there we go, it's all right. Nick, this config file is the Big Tree Tech Octopus one. So it should be absolutely fine. But the evidence suggests it isn't. This is why I prefer, I mean, I had the Klipper config I did on my own machine that I had literally no guides or anything on. was smoother than this. Because I did it from scratch, so I knew what was there. You set everything up, like if you don't know, put everything without any direction switching, and then switch the ones that you need to, rather than having some on, some off, and then, oh, it's just a nightmare. Right, let's have another go. Y10. Oh. So Y is now going in the wrong direction. How do I stop? Disable stepper motors? Oh, please tell me there's a disable stepper motors button. That's going in the wrong direction. Thank you all. It's really slow to respond to this interface compared to the Duet web control. Now they're both going in the wrong direction. This is so fun. So now we're in this scenario, so now we can do direction pin for X and direction pin for Y. It shouldn't be, it's not the home direction problem because I'm not running a home command yet. I'm just doing a move command. That's correct. Bit noisy and rattly, but it is correct. I mean, it could be because I'm network connected and all sorts of other stuff at the same time. It's just other things going over the network. I don't know. It's not particularly optimal. Hallelujah, we're going in the right direction. That only took like an hour, didn't it? Holy shit. Right. So now let's go back to config. Let's take out this. I suppose we could just set it to false, but I'm going to remove it. This is really not the time to ask how to add multiple probes to a bed, sorry. I'm also probably not the right person to ask, given my current track record. So that now won't work, that's okay. So now we can do home X, ready, go. That's okay. Home Y. Okay, let's home in properly. And home Y. The Z axis should really go back down. It should go down now it's finished, because otherwise if you keep home it's just going to keep going up. I love how much printer.cfg is getting everyone hit by the bot. I'm so sorry. Right. What are we on now? 2 hours, 16 minutes. It's alright, it's alright, it's alright. We're going to carry on. Oh, let's get rid of this. We don't need these now. So, next step. Bed locating. The print bed location of the V2 is much more adjustable than any of the other models. Before the 00 point and Z end stop locations are set, the physical locations of the Z end stop and print bed need to be finalized. The Z end stop should be located at max Y. The Z end stop should be located at max Y position, home X and Y with G28XY, and then traverse just X to locate a Z end stop position at the maximum Y travel that will trigger the Z end stop. Lock down the Z end stop at that position. Okay, but I need to move everything down, so we're going to use a cheeky M84 to turn all the motors off, and then we're just going to force it. Nice and gently. I'm sure you're all going to tell me there's a better way to do it, but I don't care. Right. Home X. Of course it's going to go up. Of course it's going to go up. Home Y. And then we're going to jog X. Which one's X? Presumably this. So what are we at position wise? X207. Y300 Z10. Right. I think brain's starting to get a bit tired. I might want that force move back so I can move down onto the Z. We've had like 100 people for the whole of this episode though. By the way, don't forget to like the video. Because everyone likes disasters like this. Well, it's not been a disaster, I'm overdoing it really. Just learning as we go. As I said at the beginning, this is not really a guide. Hopefully at this point that's abundantly clear. So we can do the home X. Do the home Y. And then where's the console gone? Yeah. So presumably we can do Z equals 100. And now we can jog Z downwards. Yes, power. So why is it put X, Y? Oh no, that's not what I want. Oopsie daisy. We need 300. So now we've... I suppose I could have just ignored the X and Y in that command, couldn't I? That's all right. So if I just put 207, will that move it to 207? Yes! Now we can move Z down. Oh, no, that's Y. Right, that's getting a bit close, isn't it? Shall I make this a little bit larger? Is that going to help? Or is that just going to cover more of the screen? I imagine you can't see too much anyway. Okay, so this position, I think we're fixed. This is good. Happy that direction. Let's make sure we get this one right. Oh, didn't mean to do that. Press the wrong button. Let's put it back to 207. And 2.1. And we'll move X a little bit at a time. A little bit too much. Back a smidge. That looks reasonably close. Oh, 206, excellent. Ah, yes, yes. Once it knows Z, it knows it doesn't need to move it. That does make sense. So I need to set this for my Z Pro position, don't I? Once the Z is fixed into position, base plate should be adjusted so the end stop pin is approximately 2 to 3 millimeters from the aluminium base plate. Okay, so we can move all of that. That's a bit too close. 2 to 3 millimeters, somewhere there. That was pretty close anyway. Why is it not? Okay. X206. So the print bed, move before the Z point, set the physical end stop. The Z end stop should be located Y max, home X and Y, traverse X, locate Z. End stop position at the max and Y travel, that will trigger the Z end stop. Lock down the Z end stop to that position. Once the end stop is fixed, the base plate should be adjusted. The base plate should be measured on each side to ensure it is centered and level, or even with the front edge of the frame. If in that process the extrusions the base is mounted on have to be moved, double check the Z end stop to affirm it can still be reached. When tightening the mounting screws for the bed, a good practice is to have one screw tight, two firm, and the last one loose. Okay, I've just not put the third one on. I mean, it's pretty square. I think it's square enough. Yeah, I probably would. It's a good point actually. There's no room for thermal expansion, is there, on this? Is that why it's saying one firm and two whatever it was? When tightening the mounting screws to the bed, good practice is to have one screw tight, two firm, the last one loose. Okay, well, we'll just keep these ones loosey-ish at the moment. Start by rerunning G28XY. Using the software controls, move the nozzle until it's directly over the Z switch. Send an M114 and record the X and Y values. Aren't they just these? Yes. Update the homing routine in the printer config file under homing override or safe-z home with those values. Okie dokie, let's go find it. Homing speed, retractors, let's go safe. XY location of the Z and stop switch. So X was 206 and Y was 300. If you want a challenge, try and build one of these without instructions or on a live stream without knowing how to do it. Yeah, I'm going to put it to 5. What do you mean I haven't located 0, 0? It said do this end stop switch first. I've defined the Z probe and I've defined this. Oh, I thought, no, I read, okay, sorry. For some reason I read this is for one printer and this is for someone else. Yep, I have rushed ahead. I do apologise sincerely. Right, depending on the bed location, the positional parameters may need to be adjusted to relocate the 0, 0. Start by rerunning G28XY. Home XY. After this, the nozzle will be at the maximum XY as defined by position max under stepper X, stepper Y. Using the Octoprint or main cell controls, move the nozzle to the front left corner of the bed. something a bit faster than that's going to be useful. 25. I wasn't suggesting I was doing it without instructions. That was not what I was getting at. I'm saying doing it without instructions would be difficult. I can't make it to the front of the bed. Why do they home at plus? Because that's what the design decided to do. It doesn't really matter where you home. So, I mean, the front of the bed is about there. I can't get any closer to the front, so I'll probably lose some distance in one direction. To be honest, I'm not quite there for this. Difficult to get right. That's right, the limit. Is it 0? Because that's the closest I can get. If from the front left corner of the bed cannot be reached within 3 to 5 millimeters, the bed location needs to be physically adjusted if possible. Move the bed on the extrusions or move the extrusions to get the bed location within range. For V2, make sure whatever bed position results still allows the nozzle to reach the Z end stop. Well, this is not going to work. It's not possible. The bed can basically not move any further back. The Z end stop can't go any further back. So the bed, like this, I mean, the bed's 305 anyway. It doesn't matter if it doesn't get to the corner, does it? Oh, am I not? Yeah, of course, okay. I understand. Yeah, so that's off the back of the bed by a smidge. To be honest, I'm pretty fine with it exactly as it is. And now I'm happy with that because I've not changed those limits. So I'm going to have to risk it now. No, it's alright, you go for the spam, it's fine. It's not irrelevant, so if it was irrelevant then I would ban you, but it's not, so it's fine. I want some extra Z room really, just in case. So let's move it all up. Z is very slow. Why does Z go so slow? I guess the motors have to spin pretty fast, don't they? So we've got finger on the restart button. Let's go for a home all. Let's do a... This could be a dramatic, epic disaster, so let's make sure we at least get it on camera. Button ready, home all, go. Fingers crossed, fingers crossed, fingers crossed. Please, please, please hit the still. Let's test it. Okay, so that would work. Let's try again. It looks like it's going to miss. Oh! Whew, we made it. We made it to the ZN storm. Holy shit. Right, we can move freely. Right, let's move these to like the middle. So, probe testing. When the tool head is in the center of the bed, reconfirm that probe is working correctly. When it is far... Oh, let's go back to this. When it is far from the bed, query probe should return open. Let's give it a go. Where's the console? All the way down here. Paste. Oh. Query probe shows triggered. Let's go sort the config out for the probe. Oh, probe, not prove. Probe, not that. Good shout. Open, excellent. When a metal object is close to the probe, query probe should return triggered. If the signal is inverted, slowly reduce the Z height and run query probe each time until query probe returns triggered. Make sure this nozzle is not touching the print surface and has clearance. So we're going to take this and move it down. No, we're not, because we haven't homed. So we're going to rehome. I don't know where there would be a red LED for the probe. I'm not seeing any probe lights. Maybe the wiring is a bit not quite right. No, because it changed. We'll get at this homing. This is so nerve-wracking having it home on this tiny little pin. Bloop. Bloop. Now we'll go down. We'll go down maybe a bit faster. Of course. There doesn't seem to be a light in the probe on this one. Open. Can it drop below? Yes. Still open. Oh shit. It's pretty close. We're going to have to... I suppose what I can just do is go like this. We'll just move the probe to the... move the bed to the probe instead of moving the probe. Where's query probe gone? There. Open. Well, that clearly doesn't work. What the dickens is going on there? I used the probe port. I'm pretty sure it told you which one to put it in. Do I need to use a different place? Is that the problem? Doesn't seem to be sensing at all. I think I might have plugged it into the wrong space. I've plugged it into the BL Touch one. Power supply is a bit warm. I think it's not getting power at all. So where's the... DC ground PB7, I think that's what we've plugged into. One down there. Diag 7. If it's an inductive sensor, you need to use the pin with the diode. J34 right there next to J40, bottom right corner. This one here. The jumpers won't matter because we're not supplying voltage to them. Yeah, I believe the diode is installed, although I didn't check. So you're saying switch to pin PG15 rather than PB7. I can't imagine it makes much difference because it's just a sensor. It's just a... Well, I'm happy to check. Oh, it's off now. Is the little squiggly line? I'm going to go check the thing now. Because squiggly line is something, isn't it? I can't remember. What's the squiggly line? Is that tilde? No, that's the... Is it? I can't remember. Oh dear. Did I not turn it on? No. Ooh. I'm going to have to stop soon. I'm really getting past it. Come on. Microphone's going to end up running out of battery. Oh no, we're only halfway. That's got plenty of time. PB7 is what's used. So PB7 is the one on the sensor, so that's the one it's expecting. You're suggesting switch to PG15. Pull up is when it is this, isn't it? That would be pull up. I can't remember what the squiggly line is. It should be pull up PB7. Well, this is a great config file, isn't it? I guess it's suitable for all sorts, apart from my sorts. Okay. Boom. Is it on? Is everything? This is a different view. I know. All view. Okay. I'm still not getting a light. Is there a light in the? Come on. I hope the probe isn't dead. It's the flipping pricey one. It's now saying triggered. I'm triggered, mate. Unless my metal object's not big enough. There's definitely no light. But that suggests it's not getting voltage, doesn't it? If it's not getting any voltage, then maybe the wiring is a bit balls. Well, yeah, it now says trigger. Before it said open when I did this. We've put pull up resistor, and now this is a nightmare. Oh dear. That still says triggered. Triggered. I think I'm going to stop there. I'm getting exhausted. I need to try and solve this without 10 different people telling me different things to do, because that's not very productive. We will get it sorted. I'll show you in the next episode where I got to and what the solution was, what works and what doesn't. I will try that diag 7-pin and all sorts of other things, and we'll see where we get to. Thank you very much for the $5 tip. How long ago did I miss that? Either way, we're stopping there. I'm exhausted. It's nearly 3 hours now. And we're not going to be printing today anyway, so we're not going to be missing anything. We'll catch up in the next episode with where we are now, and we'll get it all sorted. So don't worry about it. Nothing will be missed. There's all sorts of things to check. I just don't want to do it now. I've had enough. As soon as it's like more of me doing it, more of just me following chat, it's just not very fun. So I'm going to get it sorted. I'll tell you what was up and what was broken and what was not configured right. And then we'll sort that in the next time. So thank you everyone for sticking around. Hopefully this was a good episode, even if it was a little bit here and there. Hopefully the config at the start would get you introduced, but getting the actual config file sorted for your precise printer has been a little bit of a challenge. Might have been easier starting from nothing, but there you go. At least we're getting somewhere. We're moving forward very slowly, and we will get there eventually. Just takes a little bit of time. And I'll be happy to share the config file once we're done, so that anyone else with the same thing can hopefully use whatever solutions that I do find. So yes, that's going to be it for me today. Thank you for watching, and I will see you in the next one. Good evening, good night, good day, and goodbye.